Right. In this one, the following figure shows the apparatus used to investigate the wave in a stretched string. So what do we have in here? We have a vibration generator, a signal generator attached to it, and we have a moving wooden bridge, and signal generator is attached to the vibrator. It is going to provide a motion up and down, and that is attached to a string, and that string is attached to a stack of masses, and it goes through a pulley. Okay, the frequency of the signal generator is adjusted so that the wave shown in the figure is figure seen at this frequency. At this frequency, the string vibrates between two positions shown in figure 1. So this is called standing waves, the waves that is not moving. So it has a one whole wave. So this is a half and this is the other half. So it has a whole wave. So the wavelength of the wave shown in the figure above was measured 80 centimeters. What piece of apparatus would you be would have been suitable for measuring the wavelength? So what it is any other length. What do we use to measure the length? That is a meter ruler. So we will be using a meter ruler to measure that length or wavelength. Write down the equation that links the frequency, wavelength, and frequency and wave speed. So wave speed is equal to frequency times wavelength. Or on the other hand, you can write symbol equation as well. V is wave speed, frequency F, and this symbol called lambda, that is the wavelength. Okay, so string in the figure above vibrate at 55 hertz. So frequency is 55 hertz, and calculate the wave speed shown in here. So this kind of question people forget, where they have given the data in here earlier, 80 centimeter, and make sure 80 centimeter is converted into meters. So that is 0.8 meters before you plug into this calculation. So V is equal to F times lambda. F is 55 hertz and your lambda is 0.80 meters. So the unit of velocity is meters per second. So that will be 55 times 0.8, that is 44 meters per second. Okay, so frequency of the signal generator is increased. So they have increased the frequency, and this make the wavelength of the wave to change. The wave speed stay the same. So V is equal to F times lambda, but they are increasing the frequency, but the wave speed is staying the same. So in that case, what's going to happen, the wave length has to go down in order to keep it a constant value. Let's say, for example, let's say initially they had this value. So they had 10 meters per second, and then they have 2 hertz, and then 5 meters wavelength. Now what they have done, they have increased keeping the wave speed 10 meters per second still, but they have increased the frequency to 5 hertz now. So what should be the value for our wavelength now? That should be 2 meters. So what has happened, when you are increasing our frequency, the wavelength has to go down. So describe how the apparatus could be adjusted to show the one complete wave without reducing the frequency. So without reducing the frequency, what they're going to do, so what they can do is, the wavelength was 0.8 meters. Now it is going to be smaller than that because we have increased the frequency. So we have to decrease the wavelength. So wavelength is going to be smaller. So the new standing wave that we are going to create is going to have similar to this. So smaller than that. So in order to accommodate that, what you can either do, you can either move this wooden bridge to the right, or otherwise what you can do, you can increase the tension by increase the number of mass or add a stack of mass onto this. So you can do these things. So because of this, when the frequency increases, the lambda wavelength is going to decrease. So in order to accommodate that, you need to move the wooden bridge to the right, or otherwise you can increase the tension of the string by add more mass or weight. Okay, a student wants to investigate how the speed of the wave on a stretched string depends on the tension of the in the string. The student uses the apparatus in the figure above. Describe the method the student could use for this investigation. So it is a 4-mark questions. So using this method, they are going to change. So in order to investigate the tension, what they're going to do, they're going to have the independent variable mass. So add or remove mass. So that is going to be our independent variable, and they're going to measure. So how does what they're investigating? Speed. Yeah, so they're going to measure wave speed. So wave speed is going to be our dependent variable. Okay. So in order to measure the wave speed, you need to get the frequency and wavelength. That's it. And then if you're going to keep what you're going to keep the same, you're going to keep the vibrator and all the wooden bridge, and then the temperature that can affect the tension as well. All of this same. Okay. So what you're going to say, first you can say add or remove mass from the string. Okay, and then after doing that, what you're going to do, you're going to adjust the frequency using the signal generator. You could do that, or you can adjust the frequency or wavelength by moving the wooden bridge to the left and right. You can alternate the frequency, okay, by moving the wooden bridge to the right or a left. And then what you can do, you have to adjust till you create a standing wave again. So observe a steady stationary pattern of wave or standing wave. So measure the wavelength using a meter ruler. And calculate the speed. So calculate the speed using V is equal to F times lambda. Okay, so that's all you're going to say. So you're going to alternate or change the tension by add or remove masses from the string, and adjust the frequency, or otherwise moving the wooden bridge till to find your new stationary wave position. So you could either change this signal generator different frequency to make the different wave standing wave, or you could move this wooden bridge up or down, right or left, to until you find a point where it is creating a new stationary wave position. Okay, and then using that you can measure the wavelength of new standing wave or stationary wave, and you know the frequency by using the signal generator, and you know the lambda, and then you can calculate the velocity by plugging in this calculation. You can find out the tension using the tension is going to be equal to the amount of mass that is hanging in here. So by alternating the tension, you are changing the tension, and then you are measuring the wave speed. So you can plot a graph, tension again, velocity, or speed of wave.